Hey everyone, my name is Malar Chen, and I actually lead up the infrastructure and applications product marketing teams at HashiCorp. And today I'm going to be here and I'm going to give you a quick intro into HashiCorp and infrastructure as code with Terraform. So before we jump right in, let me give you some context on our company. So HashiCorp is in the business of helping you adopt the cloud with products helping you with challenges across infrastructure ops, networking, security, application delivery. And the HashiCorp suite enables organizations to adopt consistent workflows and create system of records, and then becomes like the standard for cloud infrastructure automation. So our products have become increasingly standard for organizations adopting the cloud. Today, we have over 3,600 customers, and about 180 of those are in the Fortune 500. So let's get started. So the move to the cloud has happened, but what does this look like? So this means that organizations went from what was primarily a static data center, and this was physically located on-prem within their organizations. And now those organizations are moving to what we're calling a dynamic data center, where there's maybe some private estate and maybe some public cloud. And within that, there's a bunch of providers and variety of other infrastructures types, and we all need to interact with all that through some sort of API. So this move introduced new principle to each layer of the provisioning, security, and networking layers. And there's a lot of several fundamental things that need to be changed. So for example, in provisioning in a private data center, that meant that someone had to go file a ticket to get that infrastructure that they needed. Stack of infrastructure would then be set up, and then there's an IP to go log on to those machines. Now there's a new equivalent. So the modern equivalent is that infrastructure is infrastructure as code, where engineering or development team would call into an API for a service, and then it spins up and provisions or deprovisions that infrastructure. So infrastructure as code is really the new way this world works. So in the networking layer, static hosts moved to being service-based, and security that was done by IP is now identity-based. So these new principles drive organizations to this idea that, hey, there's this new approach to how we interact with our infrastructure. So navigating cloud adoption is a challenge that those organizations need to solve, but there's actually an established pattern, what we really see as a blueprint for how to solve this. And so we call this a cloud operating model. And I know that this is really a simplification of reality, and the real world doesn't always fit into this. But Rosemary will dive deeper into this later, and you'll have the opportunity to ask questions and during the technical breakout. So in general, when we look at how people adopt the cloud and our customers, we see three typical phases for the organization to get to a cloud operating model. We know in the first stage, organizations are going about and have application development teams looking for new tools to help them with their problems around provisioning, securing, connecting, and running networks and applications. And so for the provisioning layer, you might have Terraform open source in there. You might have cloud native tools like Azure Resource Manager or CloudFormation, or really just like a variety of things that are already out there in the market. What happens out of this is that you have multiple different workflows because everyone really chose what was best suited for their needs. And we call this tactical cloud. And that's the first approach at getting to this cloud operating model. However, we really quickly see that people get challenges that come out of this first approach. First off, you have disparate workloads. Your teams are really spread out. They're not really using any consistent workflow, and there's not a good way to bring everything together. So you have sprawl and no central knowledge share. So how do I actually know what infrastructure I have provisioned? And that leaves all these organizations up to vulnerabilities. So organizations realize this, and then they move from this tactical approach of cloud adoption to actually having a cloud program. And that's going to be run by a central team. And they're tasked with creating a central service around a lot of these things, around provisioning, security, networking, and connecting services, all of the ultimate goal of building your applications. So in this last stage, organizations start folding in maybe private estate and applying the cloud operating model more broadly. So this is really where HashiCorp can come in and help our customers deliver that standardized shared service across each stage. So for example, in the stage one, it's really ad hoc. People are adopting new cloud services and leveraging tools that are built by developers to help them with their specific jobs. A lot of this is like open source projects. And then in stage 2 and 3 is where the cloud platform team comes in, and they're trying to do that standardized workflow. And there's a cloud system of record so that's efficiently managing their infrastructure. So for example, this is problems like visibility, observability solutions. So you have to have audit logging and compliance tools. So for today, let's focus on the infrastructure provisioning layer. So with the goal with infrastructure provisioning is you want infrastructure as code platform that becomes a shared service to the rest of an organization. So that needs to be able to provision cloud, networking, private data center, or SaaS. So as organizations, like a lot of them will get started on cloud adoption, maybe they'll start with the infrastructure provisioning workflow and using infrastructure as code to go provision the infrastructure that they want. So this could be AWS, it could be Azure, and it's all about getting started with that first cloud. And then you want to take that use case and then be able to provision infrastructure and to deploy applications on top of that infrastructure. And then organizations can move on and they want to get more of their infrastructure in this model. But the great thing with Terraform is that you can use the same workflow to do their networking, the same workflow to do their private data centers, and then also be able to use that same workflow for SaaS applications. Terraform does all that, and that's how it's become the standard for infrastructure as code to provision, and it also has the ability to manage infrastructure throughout its life cycle. And so this really isn't an easy task, and Terraform is able to do all that very consistently because we have over 3,000 different providers in our registry. So it is really fair to say Terraform can do infrastructure as code for any type of infrastructure you're working with. So like I said, Terraform is able to work with all of your infrastructure because of the breadth of the provider ecosystem. Today, Terraform has over 3,000 providers, and that continues to grow. In fact, when I first made this slide a couple months ago, we were at 2,800. And this grows because Terraform provides extensibility to partners, community members, and HashiCorp employees, and they all create, publish, and maintain providers. So these are anything from your biggest cloud providers and developer tools that you're already using. So the AWS's, Azure, GCP. And if you're customers, they also receive support. So we have over 12,000 modules to get you started, and you can leverage our over 20 run tasks partners. And those are things that cover security and code scanning, cost control, and regulatory compliance. And that allows you to inject context from a third-party service into the Terraform workflow. So one example we have is using HTTP Packer to check that you have the latest image that is compliant. And all of our ecosystem is located in one central repository. That's the Terraform Registry. And we see our customers getting a lot of value out of standardizing and centralizing infrastructure provisioning using Terraform. So what's really interesting here to note is that our customers choose Terraform Commercial because it helps them realize the business value, where a lot of the do-it-yourself models with open source projects kind of leaves them in the phase one of the cloud operating model that I went through. So let me get right into this. So after adopting Terraform, a lot of customers are able to go to market faster because provisioning infrastructure takes less time. So how are they able to do that? Using Terraform, developer teams are able to be more efficient and they can collaborate easier. And really, they don't need to rebuild the wheel every time they need infrastructure. Terraform allows those customers to collaborate using VCS integrations for CI/CD, and then they can reuse those common building blocks in modules that are curated and shared in a registry. So this ultimately leaves a lot of teams to self-service infrastructure and then have all the security measures in place without lengthy waits for IT to approve requests. Another benefit we see Terraform providing is that Terraform can help you with costs. So we've seen a variety of percentages starting at 30, going all the way up to 70, that cloud spend is wasted. That means what happens is anyone can provision infrastructure. That means anyone in your company can spend money if an organization doesn't have a management system in place. So we see organizations who use Terraform to help manage their over-provisioning or rein in unnecessary compute from their developers. So how they do that is that they can use Terraform, they can implement guardrails, they use policy as code to prevent any over-provisioning, and then they can also embed best practices into modules that developers can reuse. And of course, moving your provisioning into a centralized cloud team on a central platform helps with that overall visibility, so you can see where a lot of these costs are occurring and what is the best way for your organization to optimize your spend. The third benefit we have here is that Terraform, from centralizing that infrastructure provisioning, is that it helps you by minimizing risk. So there's a lot of ways that Terraform helps with risks. We have policy as code, which helps restrict vulnerabilities. Terraform also helps you by unifying all those different workflows that you might have had in your organization into one single provisioning workflow for all your infrastructure. So this means that all your operators and developers need to learn one thing, and that helps by limiting the number of misconfigurations that might happen from a lack of expertise. In addition, because we have modules, those experts on your cloud team can create those modules for those with less expertise to consume without accidentally opening your organization up to risk. And then after your initial provisioning, we have drift detection, and that provides automatic alerts when infrastructure changes and really helps you make sure that you have the health of your infrastructure. And of course, getting the state files and secrets off of local machines just helps with security. So here I kind of just highlighted that Terraform has a lot of functionality to help with this, day one when you're provisioning to the day two and beyond in management. So at HashiCorp, what we're really building and what we're invested in is creating that best-in-class infrastructure provisioning workflow and delivering the capabilities that organizations need for their platform team to standardize on the workflow for their users and enable infrastructure management and be able to use and operate at any scales. So I want to point out that these are all features that we know that the platform and the cloud team needs, and this is all stuff beyond open source. And a lot of the home-built options don't provide that full set of capabilities, or you have to have a team to go build that and maintain it. So a lot of these core capabilities comes down to 6 different groupings. So first is I need to unify my workflow, and that means I need to be able to manage that workflow. So this means I need features like RBAC, remote state storage, and a registry to leverage reusable components and no-code workflows so that developers can self-serve infrastructure. Number 2 I have here is Terraform has the policy security and compliance that are needed by the cloud platform teams to minimize risk. So I need to have things like Sentinel, which is in Terraform, which is our policy as code. We have OPA policy, and we can leverage other policies from third-party vendors using run task. And then in Terraform, you can automatically enforce these policies. Terraform also has visibility and optimization to help you with the infrastructure lifecycle after you provision. We have workspace management, drift detection that I just went over a little bit earlier, and continuous validation. These are all things that help with the health of your infrastructure and providing you automatic alerts and audit logs. And then finally, we have remediation with rolling back or forward. We work with a lot of the biggest companies out there. So of course, we have a lot of the reliability and scale features that are needed, as well as governance, risk and compliance and support. And the last piece that makes Terraform so powerful, is something I went over earlier, is the integrations and the API-driven workflows. What Terraform also does is that we grow as an organization grows and their cloud maturity grows. So this is how we see Terraform being used as a customer goes through a cloud operating model. So in the first stage, they're adopting the cloud. Maybe you're in your tactical cloud, and your initial use cases with Terraform might be initial infrastructure adoption, infrastructure as code, and creating the foundations for team management and CI/CD. So in some cases, this might be private data center, or it might be cloud. But however, as you move to the stage 2 of this, the thing that you're focused on is standardization. So you're trying to establish the cloud platform team and standardizing workflows and tools. Your additional use cases might be, how do you add in additional infrastructure? So maybe if you started with data centers, now you're adding networking or cloud. But at this point, you're invested in ensuring that there's policy, governance, and compliance for security, and then get the right notification when there's issues. And then the last stage is when you're trying to scale. And this is when you're trying to add in most or all of your infrastructure and then have that self-service model where people can get the infrastructure that they need while you maintain visibility. And then you're able to optimize things like cost. Terraform can help you throughout all this. And then depending on an organization's need, you can use fully managed Terraform on Terraform Cloud, or you can self-manage with Terraform Enterprise. And these are just our commercial offerings. So of course, there is open source Terraform as well. And I really wanted to show you this quickly because on the left, we have our application developers and platform teams, and they're working together, and they kind of have slightly different focuses. The cloud operating model enables that platform team to deliver the common set of standardized shared services. And this is across infrastructure, security, networking, and application layers. So that applications team on the top right there can deploy their applications across any infrastructure. And this is really where HashiCorp comes in with the full stack of products. We help you unlock the cloud operating model. And then here is kind of how we see this. So Terraform can only be the start of how HashiCorp helps. As you progress, through the different stages, we have a full stack of products to help with the different challenges. So these are things that might help with image management, identity-based security, networking, and application scheduling and development.